Hello, today's notes are on proving triangle similarity with AA similarity, postulate, side, 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 similarity theorem, and side angle side similarity theorem. So let's get started. In this case, if two angles of one triangle are congruent with the two angles of another triangle, then you can say these two triangles are similar by the angle side angle postulate. Sorry. By the angle similarity postulate. So let's say triangle DEF is similar to triangle ABC because they gave two congruent triangles, two congruent angles. So sorry. I need to think before I speak. Let's try these out. These are saying let's determine if these are similar. So we just need to find two angles that are the same. In this one, it's super easy. They're giving us two that are the same. So yes, these two are similar. Triangle ABC is similar to triangle DEF by the angle similarity postulate. Let's try this one. Now we got to know something about parallel lines. What do we know when we have a transversal? That we've got some corresponding angles that are congruent with each other. And we also know that they share this angle, so those are congruent. That means this little triangle is similar to this bigger triangle and they share the same angle. So yes, we can say that PQL is similar to NML by the angle similarity postulate. How about here? We've got vertical angles that are congruent and then the ones that they already gave us. So that is two triangles, two angles. So we can say that triangle XVW is similar to XYZ by the AA postulate, AA similarity postulate. In this case, on the next one, we see that they both have a 68. We see that these two don't line up, but if we can figure out what this third one is, we can see if it matches. So upon finding them out, remember 180 degrees for a triangle, subtract the ones you know, and we're going to get 58 for this one, so it looks like it's not going to work out. This is 49, so no, these are not similar. Next, we're going to look at side, side, side similarity. Remember, similar triangles or similar polygons have to have proportional sides. So you can prove that these are similar if they give you if they give you corresponding sides of two triangles are proportional. Well, how do we find out if they're proportional? We're going to find out the scale factor. So the 12 is going to go with the 4. Let's divide it out, and we're going to get a 3. In this case, 18 divided by 6 also gives us a 3. And 24 divided by 8 also gives us a 3. So we can say that triangle DEF is similar to triangle ABC, but this time it's by the side, side, side similarity theorem. All right, remember we're looking for proportional sides, and how do we figure out which go with which? Well, here's the smallest one. Let's do it with the smallest one of that. And we're going to find the scale factor of each. Here's the medium side, and then here's the longest side of each. We're just going to do the scale factor, I think. All right, so 3 over 6, that's 1/2. 3 over 6, and then the yellow was 4 over 8, and 5 over 10. So, by the side, side, side similarity theorem, we can say that triangle QPR is similar to triangle TSU. What's going on here? We've got small, medium, large, small, medium, large. So they're lined up pretty easily again on this one. The smalls go here, the mediums, large. Okay, let's see what we get. 30 divided by 24 gives us 5/4. I believe it's also 1.25 if you get the decimal version. 35/28 was this one, which is also 5/4. And then the green one was 32/35. And we can't reduce that. I did do the decimal version of that, and it was 1.28. So you can see that these are not similar because they don't have the same scale factor for all three sides. Alrighty. Alright, I've highlighted the smalls for this one. Here's the medium. And here's the large. Alright, I'm going to start with large since I have that color ready. Okay, let's see. We need this one. We need this one. Okay, so for the blues, we have 12/7 or 7/12. Just make sure you keep it consistent. So since I'm going this way, I'm going to keep them all going the same way. So 12/7, I'm going to do 16/10 so that it matches the same way. And then 5/4. And let's see. The only one that can reduce, I already know they're not similar because these won't reduce anymore, and this one reduced to 8/5, so no, these are not similar. And then the final thing we're going to look at is side angle side similarity theorem. If they gave you two congruent angles, and then if the proportional sides to those right next to them, if an angle of one triangle is congruent to an angle of a second, and the lengths of the sides that include those angles are proportional, then those triangles are similar. So in this case, we're just going to check out these two sides, 6/9 and 10/15. They're both 2/3, plus they gave us the congruent angles, so we can say that XYZ is similar to DEF. And how? By side angle side similarity theorem. All right, so remember, now we're looking for congruent triangles, which they gave us, and then their proportional sides. So in this case, here's the small side that would go with this one. The larger side would correspond to this one, and we're going to see how they work out together. 50/35 and 45/31.5. This time I'll do a decimal so you can see what that would be. Okay, they both wound up being the same decimals, so we can say that they are congruent. That triangle EGF is similar to JHK, and make sure you name the corresponding side. So I did the green, then the blue, green, then blue. Next one, we know that these would be the congruent triangles, so we're going to look for the sides right next to them to see if they're proportional. So 12 with the 48, 6 with the 24. This time I decided to use the bigger number first so that you can see As long as you keep them consistent. Here we see that we do get the same scale factors, so these are similar. Let's make sure we write them right. I'll do blue and green again. So RES is similar to FEG by the side angle side similarity theorem. And then this one is important because these two triangles are sharing the same. So we've got a big triangle and then a little triangle. They both are sharing the same angle there. So we just need to make sure that their corresponding angle sides are proportional. So is this one and this one proportional with those two? So let's go. Let's find the scale factor of both. Okay, so 15 to 25, or we'll go do the other way again. 25 over 15, let's see what that is. And then let's see what 21 over 12 is. And if we reduce this one, it's 5/3. If we reduce this one, it's 7/4, so not similar.